And welcome again to Champions Math Study. This is the final part 3 of our series on 2 mark questions from the matrices chapter. We have already covered 20 questions in the last two parts. And in this video, we will complete the chapter with the final remaining questions. Let's finish strong and get full marks in this chapter. Let's get started. So here is the next question. Find the rank of each of the following matrices. Here they have given three matrices, but in your public examinations they will give only one 3 by 3 matrix and you need to find out the rank for the given matrix. Okay, so the question carries 2 marks, and if you see here, it is repeated in March and June, because definitely in your examinations you will get one question, like most expected question is the finding of rank for the matrix. So in next slide also I have given three more matrices, so don't skip any of the matrices, just prepare all these matrices, because here finding of rank indicates like we are having rank of 3 or 2 or 1. So because we are having different cases for getting this rank 3 or 2 or 1, so each one of the question is different, so practice all these. Okay, let's see what are all the cases that we need to concentrate to finding the rank. Okay, so here this is the first case. So for case 1, and here is the case 2, and here is the case 3. Okay, so first, in the first case, like for finding the rank you need to calculate the determinant of the matrix, given matrix. Okay, so for example, if they given 3 by 3 3 by 3 matrix, and for suppose this is our A matrix of order 3 by 3, and so first you need to calculate the determinant of that given matrix. So if the determinant of the given matrix is not equals to 0, then simply you can say the rank of A is equals to the order of A. What is the order of A? 3 by 3, right? So which means 3, right? So rank of A is equals to 3. So this is the case 1. So just find out the determinant of the given matrix, and if it is not equals to 0, then simply the rank of A is equals to 3 if it is the order of 3 by 3. Okay, so here the case 2 is, again find the determinant of the matrix A, and for A of 3 by 3 matrix, if the determinant of A is 0, here the not equals to 0, then we can say order is 3. But in case of determinant A is equals to 0, then go with the order of 2 by 2 matrix. Okay, go with the order of 2 by 2 matrix. So the determinant of 2 by 2 matrix is not equals to 0, so then you can say the rank of A is equals to order of that matrix. What is the order of this sub matrix? Like minor matrix is 2, right? So rank of A is equals to 2. If the determinant of submatrix is not equals to 0, and the 3 by 3 matrix determinant of A is 0, then we can say the order of the rank of the matrix is 2. And here the third case is the determinant of A is equals to 0, and for all sub matrices of 2 by 2 is equals to 0. So the determinant of submatrix of order 2 by 2 is also, sorry, is also equals to 0, then you can say that rank of the matrix is 1. So you can say 3 if the determinant is not equals to 0, and if the determinant is equals to 0 and the submatrix is not equals to 0, then you can say the rank of order is matrix is 2. And case 3 is if the determinant is equals to 0 and all the submatrix of determinant of submatrix of 2 by 2 is also 0, then you can say the rank of A is equal to 0. Here the submatrix is nothing but, if you see here, if this is our matrix of order 3 by 3, and this is the submatrix of this order of 2 by 2. Okay, this is one submatrix, and this is another submatrix. This is the first submatrix, second matrix, and this is the third submatrix, and this is the fourth submatrix. Total you will have four submatrices for 3 by 3 matrix. Okay, you need to if for suppose this determinant is equals to 0, then you need to um calculate the determinant for all these submatrices of order 2 by 2, because if any of the submatrices is not equals to 0, then you can say the rank is 2. Okay, you got it right. So let's move on to the each and every question so that you will get more clarity on this. So let's move on to the first one. Finding the rank is very very important, so don't skip. Okay, so here is the first question I am taking. So let A is equals to matrix of 1 1 1 1 1 1 and 1 1 1. This is the order of 3 by 3. So just I am considering the determinant of that matrix. So A is equals to 1 1 1 1 1 1 and 1 1 and 1. So determinant, I already said, right, determinant is calculated with the first one. So take the one and just ignore this column and row. So just multiply these opposite elements and perform subtraction. So 1 into 1 is 1 and 1 into 1 is 1, so minus 1. So for first one you will get plus and minus and plus. So second one take minus of 1 and ignore this row and this column. So 1 into 1 is 1, minus again 1 into 1 is 1. Now plus 1 into, ignore, skip this row and this column, just take the opposite of these two. So 1 minus 1. So finally 1 minus 1, 1 minus 1, 1 minus 1, totally you will get 0. What I said previously, if the determinant of 3 by 3 matrix is equals to 0, then we need to check for the submatrix, right? So then consider the submatrix, assume that as a matrix B. So let B is equals to 1 1 1 1. I'm taking the submatrix of this first matrix, see here. So taking this first submatrix, okay, so 1 1 1 1. So from here, so I am calculating the det B. So det B is equals to simple 1 minus 1 is equals to 0. So here all the elements are equal, right? All are 1. So for all the submatrices, you will get the determinant as 0. So here you need to say all 2 by 2 submatrix det is 0. Therefore, the rank of A is equals to 1. This is the third case, right? According to the third case, so we can say the determinant of order of 3 by 3 is 0. So then we need to move on to the submatrices. If the all the submatrices of determinant is also 0, so then simply we can say that rank is 1. Okay. So the next one. So here's second question. So let A is equals to 1 4 minus 1 2 3 and 0 0 1 and 2. So this is the second matrix I am taking. So just I am taking the determinant of that A. So 1 4 minus 1 2 3 0 0 1 and 2. So I am finding the determinant. So 1 into 6 minus 0. So minus 4 into 4 minus 0. So minus of minus plus 1 into 2 is 4 minus 3 zeros are 0. So finally you will have 6 minus 16 plus 4. So finally you will get, so here minus 1 is there, right? So here you will get minus 1. So minus 1 into 4 minus 0 is here minus 4. So finally 6 minus 4, so 2 minus 16 is equals to minus 14. Sorry guys, I did something mistake here. So again I will calculate the det for this matrix. So 1 into, so 3 2s are 6 minus 0. So minus 4 into, skipping this row and column. So 2 2 is 4 minus 0. So minus plus or minus minus. So minus 1 into, so ignoring this row and column. So 2 ones 2 minus 0. Okay, good. So 6 minus 16 minus 2. So from this we will get minus 12 as the determinant value, which is not equals to 0. So this is from the case 1, right? Simple. If the determinant of A is not equals to 0, so then we can say the rank of A is equals to order of that particular matrix. So therefore the rank of A is equals to, this is the matrix of order 3 by 3. So therefore the rank of A is equals to 3. Okay. So next quiz. So third one. So let A is equals to 1, 2, 1, minus 1, 0, 2, 0, 1 and minus 1. So from this I am calculating of determinant of A. So det of 1, 2, 1, minus 1, 0, 2, 0, 1 and minus 1. So from this I am calculating the determinant. So 1 into, so 0 minus 2, so minus 2 into, so minus 1 into minus 1 is plus 1, so minus 0, so plus 1 into, so minus 1 minus 0. So from this minus 2, and from this here we will get minus 2, and here the minus 1. So total we will get minus 2 minus 2 minus 2 is nothing but minus 5. Here also the determinant is not equals to 0. So according to the case 1, if the determinant of A is not equals to 0, then simply we can say the rank of A is equals to 3. Okay. So next question. Yeah, this is the fourth one. So I'm taking the fourth one. So let A is equals to 1, 2, 0, minus 1, 3, 4, 1, 2 and minus 2, 3, 2 and 5. Here what is the order of this given matrix? So total we are having 3 rows and 4 columns. So this is the order of 3 by 4 matrix. But we are not able to find the determinant for this 3 by 4 matrix, right? So just I am considering the 3 by 3 matrix. So that I am assuming it as B. So let B is equals to 1, 2, 0, 3, 4, 1 minus 2, 3, 2. So let be a submatrix of A, right? So this is one 3 by 3 matrix. You can also consider this 3 by 3 matrix, second 3 by 3 matrix. That is not an issue. It's up to your choice. So just I am considering the first submatrix. So I am calculating the determinant of this B. Okay. So determinant of B is equals to 1 into 4 twos 8 minus 3 minus 2 into, so 3 to 6 minus into minus is plus 2. So plus 0 into anything is 0. So from this you can say 8 minus 3 is 5 minus 2 into 6 plus 2 is 8. So 5 minus 16, which is nothing but minus 11. So which is not equals to 0. Thus we need to check whether the determinant is equals to 0 or not equals to 0. Here the determinant of A is not equal to 0. So therefore the rank of the B, right? So rank of the B is equals to order of that B matrix. What is the order of the B matrix? Is 3 by 3, right? So the rank of B is equals to 3. So we can say the rank of A is equals to, if the submatrix is not equals to 0, then simply we can say the rank of that matrix is uh, 3, right? So rank of A is equals to 3. The next one. So let's I'm taking the fifth question. Okay. So let A is equals to 1, 0, minus 4, 2, minus 1, 3. And this is the matrix of order 2 rows with 3 columns. So 2 by 3 matrix. So we can't able to find the rank for this type of matrices, right? So I'm taking B. Okay. So B matrix. So submatrix of this A matrix, I'm assuming it as B. So B is equals to, I'm just taking the 2 by 2 matrix from this 2 by 3 matrix. So first 2 by 2 matrix I'm considering. So 2 into minus 1, be a submatrix of A. So assuming like calculating the determinant of this B. So 0, 2, minus 1. So from this 1 into minus 1 is minus 1 minus 0 into 2 is 0. So from this we will get as -1, which is not equals to 0. So therefore determinant of B is not equals to 0. So therefore we can say this is the order of 2 by 2 matrix, right? So the rank of B is equals to, sorry, directly we can say either rank of B or rank of A. So because B is also submatrix of A only, right? So directly you can say the rank of A is equals to, since the submatrix of A is not equals to 0, which means which is 2 by 2 order. So then we can say the rank of A is equals to, order of this 2 by 2 matrix is 2. So we can say the rank of A is equals to 2. The rank of A is equals to 2. Next question, like the next one, sixth one, you can try, just calculate the rank of this determinant of this matrix, taking the red one. So just, yeah, just calculate the rank of, sorry, it was not visible. Yeah, just calculate the determinant of this A matrix. If the determinant of A is equals to 0, then go with the sub matrix. If the determinant is not equals to 0, then you can say the rank is 3. If the determinant A is equals 0, just take the sub matrix of this order of 2 by 2 with 1 2 2 3. So just calculate the determinant of, assume it as B, and calculate the determinant of this B. If it is not equals to 0, then we can say the order of that given matrix is 2. Okay, just try by yourself. It is not that much of difficult, very simple calculations only. So move on to the next one. Yeah, all right. You have been learning actively so far. So now it's your turn to try. So this question number 25 is for you to solve. So find the rank of the matrix of this A matrix. So solve this and comment your answer in comment section. I will pin the correct answer and reply to your comments. So let's test how well you understood the concept of rank using this determinant. Let's move on to the next question. So here is the 26th question. So if A is equals to, they have given one matrix of order 2 by 2 and one condition called A square plus B square plus C square plus D square is equals to 1. Okay. So then find the inverse of A. So we already know, right, how to calculate the A inverse. So for example, if A is equals to, assume here we are having 2 by 2, right? So assume A is equals to A B C D. So then A inverse will calculate as adjoint A by det A. So adjoint A. So adjoint A is given as, so just interchanging the A and D values. So here D and A, and keeping the same B and C at the same place with the negative sign, and this is how the adjoint A will be looks. And the det A is equals to A into D, just subtraction of these opposite elements. So that A is equals to AD minus BC. So therefore A inverse is equals to 1 by AD minus BC into adjoint of A, which is D minus B minus C and A. So from this I'm removing this A. Yeah, yeah, so this is our A matrix, right? So here we need to first calculate the, just calculate the data of this A. So we need to find the A inverse, right? So first I'm taking the data of A. So if you want to mention, you can mention like A inverse is equals to adjoint A by det A, and finally this is the main formula you need to mention for A inverse. So A inverse is equals to, A inverse is equals to 1 by AD minus BC. So first I'm considering the det of this matrix. So det A is equals to, assume this as A. I'm taking the red one. This is not looking. So this is A and this is B and this is C and this is D. Okay. So from here, so det A is equals to A into D. So A into D means A plus IB into D is A minus I into B. So minus B into C. So B is C plus ID into C. C is minus C plus ID. I'm removing this. Yeah. What is this? Minus C into, minus C plus I into D. Yeah. So this is, This is what we need to calculate. Okay, so from this we can say, just taking the or else is this is in the form of a plus b into a minus b, right, which is a square minus b square. So a into a is a square, minus b is ib, right, so ib whole square. So minus, this is also in the form of a plus b into a minus b. So here also I am taking, here we can say this is an a and this is a b. Okay, so a square, simply I will take id square minus b square, so simple c square we can take. Okay, so from this, a square minus ib square means minus I square into b square, right, minus I square into d square minus c square. So from this we can say, for complex numbers, we know I square is equals to minus 1. So therefore I square is equals to minus 1. We can take a square minus of minus plus, I square is minus 1. So minus into minus plus. So b square minus, here I square is there. So minus, minus 1. So minus of minus is plus d square minus c square. So we already know a square plus b square. Sorry, here minus is there, right? So this is total minus. So here this is also in total minus. So here minus of minus it becomes plus, and minus of minus this is also becomes plus. So from this, a square plus b square plus c square plus d square it becomes. So finally the value is 1 according to the given condition in our question. A square plus b square plus c square is equals to 1, right? So is equals to 1. So simply here itself I'm removing this here because it's little bit confused. Okay, so this is the a inverse, right? So from this I'm calculating a inverse is equals to adjoint a. So d is a minus ib. So minus b means minus of c plus I into d, and here minus c means minus of minus c plus id, and here a is a plus ib. So just, and here det a is ad minus bc values is 1, right? So 1 by 1 we can take, anyhow we will get 1 only determinant. So a inverse is equals to, so finally a minus ib, keep it as same, and here just multiply the minus with all the elements. So minus c and minus id, and here minus of minus plus, so c plus c minus, sorry, yeah, c minus id, because plus or minus minus, right? So c minus id, and finally a plus ib. So this is the final result. So simply you can say a inverse is equals to a minus ib and minus c minus id, c minus id and a plus ib. So just write, therefore A inverse is equals to A minus IB minus C minus ID, C minus ID, A plus IB. So here this is also very simple. It looks like complex, but it is very simple. See, A inverse we already know is adjoint A by det A. Adjoint A is just interchanging of A and D values and keeping the C and D values in the same place with the negative sign. So just we are taking the adjoint a, and just we are finding the determinant of a, and here the determinant of a is 1 because the given condition is a square plus b square plus c square plus d square is equals to 1. So from this you will get determinant as 1. So just we are keeping the determinant of 1. So simply a inverse is equals to adjoint of a, finally we will get. Okay, next question. Yeah, this question is important for Telangana candidates. So see here, construct a 3 by 2 matrix. So we need to build a 3 by 2 matrix whose elements are defined by aij is equals to half modulus of I minus 3j. So by using this condition, we need to construct one of the 3 by 2 matrix. So let's take me the white one. So in general, we know, So we have to write, okay. In general, we know 3 by 2 matrix is given by, let's assume this matrix as A. So how it is like 3 by 2, right? Which means 1, 2, 3 rows and 1, 2, 2 columns, right? The order of 3 by 2. So for these 3 rows and 3 columns, so here they are given like Aij. So instead of Aij, the first element I can call it as the first row element. So first row, so A1 with the first element. So second first row second element, so A1 with the second element of A2. So and here it's a second row with the first element. This is a second row with the second element, and this is a third row with the first element, and this is a third row with the second element. Okay, so A11, A12, A21, A22, A31, A33 are the elements of this given matrix. So here now we need to find this A11, A12, A21, A22, A31, A3, A32 values. Okay, if you are finding these values and just substitute those values in this A matrix, then we are done with the construction of this 3 by 2 matrix, right? So now what they have given, Aij, right? Aij is equals to half det of I minus 3j. So here this is the given condition. Here if you see here, assume this as I and j, total I values we are having 1, 2, 3, right? So here I values are 1, 2, 3, and what are the j values? So total 1 2 1 2 1 2, so only two values, those are 1 and 2. So from here just we are substituting all the values in this Aij. So for finding the A11, so A11 is equals to, so just replacing all the I and j values with the 1 and 1. So A11 is equals to half det of 1 minus 3 into 1. Okay, j is also 1, right? So that's why. So from this you will get half modulus of 1 minus 3 is minus 2, but inside the det the negative becomes positive, right? So 2 by 2 finally it's 1. So now, yeah, 1. So now take A11 is done. So A12, let's consider A12 in this side. So A12 is equals to half I value is 1 minus j value is 2, so 2 3 is 6. So finally this is minus 5, so this is by 2, so minus 5 by 2, but this is inside that, so just it's a, we have to write as 5 by 2. So now A21, so A21 half I value is 2 and j value is 1, so 2 minus 3 is minus 1, so it is inside that, so minus 1 is nothing but 1, so this is 1 by 2. And here A22, so half I is 2 minus 2 3 is 6, so this is becomes minus 4, means 4, so 4 by 2 is 2. So now here A31 is equals to half 3 minus 3, so 3 minus 3 is 0, so that's why it is 0. And here this is A32, so half 3 minus 3 to 6, so 3 minus 6 is minus 3, so minus 3 becomes 3 by 2. So these are the values. So just I am taking here, just I am writing the matrix A is equals to, so just replace these values, that's it. So A11 is 1 and A12 is 5 by 2 and A21 is 1 by 2, because I'm not having enough space, so just I'm writing here. So but you have to keep all the things very neat and clear, okay guys. So finally these are the A11, A22, these are just I'm calculating the elements by using this statement, by replacing I and j values with 1 2 3 and j as 1 2. So I'm just keeping all these elements in this A matrix. So 1 5 by 2, 1 by 2, 2 0, 3 by 2, this is the final 3 by 2 matrix. Okay, just mention the order as 3 by 2. So construction is done. So next question. Yeah, next question number 29. So write the definitions of, let me take the color. So write the definitions of singular and non-singular matrices and give examples. Already mentioned, right? If they are asking for definitions, then you have to mention the examples also. Sometimes they will ask to explain along with examples, or sometimes they will just ask define singular or define non-singular matrix, like that. So but you have to keep any one of the example in your brain so that it will create a good impression. Okay, so let's see that what is singular matrix and what is not non-singular matrix. So singular matrix is nothing but a square matrix of A. Square matrix is nothing but with the same order, either 2 by 2 or either 3 by 3, like that. Okay, is said to be a singular matrix if det A is equals to 0. So the determinant of the A matrix is equals to 0, so then we can say it as singular. Okay, very simple. Non-singular means a square matrix A is said to be a non-singular matrix if determinant of A is not equals to 0. Determinant of A is not equals to 0, then we can say as non-singular matrix. Okay, so see here in this example 8 4 or 4 2 is a singular matrix. Why? Because if we calculate the determinant for this matrix, to 8 16 minus 4 4 16. So 16 minus 16 is 0. So the determinant is 0. So we can call it as singular matrix. Okay. So from this example 2, so 3 fourths 12 minus 0, 0 into 6 is 0. So the determinant is 12. So which is not equals to 0. So we can call it as non-singular matrix. So the next one. The question number 30. So if A is equals to one matrix of order 3 by 3 and B is one matrix of order 3 by 3, and here we need to perform, and x is equals to A plus B, then find x. So here we need to find the x matrix which is getting by the addition of this A and B. If you are performing any additions or subtractions, just we need to check the orders whether it is same or different. So here both are 3 by 3 matrix only, so we can able to perform the addition on these matrices. Okay, so from here x is equals to A plus B, right? So x is equals to, what is the A matrix? 3 2 minus 1 2 minus 2 0 1 3 1, plus the B is very simple only. So B is minus 3 minus 1 0 2 1 3 4 minus 1 2. So just add these two matrices by taking the corresponding elements. So 3 minus 3 is 0. So 2 minus 1 is 1. So minus 1 plus 0 is minus 1. And 2 plus 2 is 4. And minus 2 and plus 1 is minus 1. And 0 plus 3 is 3, and 1 plus 4 is 5, and 3 minus 1 is 2, and 1 plus 2 is 3. So this is the x matrix. X is equals to, this is the result. Okay, next question. So here 31st question. They have given one matrix, it's a small matrix only, it's of order 2 by 2, simple matrix. Then find A into A inverse. So this is very easy one. So see, A into A inverse we need to find. We already know A inverse we will get by calculating of adjoint A by det A. Just calculate the adjoint A, take that adjoint A matrix and just perform the determinant of that A. Then you will get A inverse with the order of 2 by 2, and just calculate the product of this A into A inverse. Take this A matrix and take this resultant matrix and perform the product with these two matrices, and then you will get the resultant matrix. Okay, so next question. So question number 32. So define rank of a matrix. So here they are asking for the definition of this rank of a matrix. So here if you see, let A be a non-zero matrix, which means the elements has to be present, which is non-zero elements. Okay, So let A be a non-zero matrix, which is not a square matrix, because we can able to find a rank for any of the matrix, right? It is not to be like a only for square matrix we can calculate the rank. You can take any of the matrix which is non-zero matrix. Okay. So the rank of A is defined as the maximum of the order of the non-singular square submatrix of A. We already said, right? Non-singular means what? Det A is not equals to 0, then we can call it as non-singular matrix. We have already solved some of the problems on finding the rank. So there also we did the same thing, right? If the determinant of A is not equals to 0, then simply we can take the maximum of that order of that matrix. So the same thing we are defining here. So the rank of A is defined as the maximum of the order of the non-singular matrix. Whether if non-singular matrix, whether the determinant is not equals to 0 for 2 by 2, so then the order is given as 2. Sorry, rank is given as 2. So if the determinant of A is 0 for 3 by 3 matrix, then we can take rank as 3. That is right, non-singular square submatrices, whether it is 2 by 2 or 3 by 3 of A. So you got it right. So the rank of A is defined as the maximum of the order of the non-singular matrix, non-singular square submatrices of A. So the rank of a null matrix is defined as 0. Null matrix is nothing but the matrix which has all the 0 elements is defined as 0. So in that case we can say the rank is 0, and the rank of matrix is denoted by rank of A. So the rank of A, this is how we can denote for the rank. Okay. So the rank of A. So the next question. This is also important for both Telangana and AP. Just repetitive question only. Yeah, question number 33, and this is the last question. So we are ending up this session with a simple problem like find the trace of this. So by finding the trace of this given matrix, so just mention the given matrix, and we already know the trace of the matrix is trace of A is sum of these principal diagonal elements. So just 1 minus 1 plus 1. So simply the trace of this matrix is 1. Yeah, and that's it. We have now completed all the important 2 mark questions from this matrix chapter. So whether it's types of matrices or operations or finding of rank or inverse, so now we are fully ready to score those 2 marks very easily by watching these videos. And this is your quick revision booster brought to you by Champion Smart Study. And don't forget to check out our videos on 4 mark and 7 mark questions next. They are packed with tips and tricks just like this. And if you found this helpful, and hit the like button, subscribe, and share with your friends. Let's make learning smart and simple together. Bye bye.